So this is my paper, the critical foreign policy benchmark, which is basically on we try to understand how AI models behave in the foreign policy questions. So I want to briefly start how who worked on this project. It's me, it's the Futures Lab and the Scale AI, which is basically our partner organization. Okay, the project is basically trying to understand when we integrate AI into the decision making, the early warning, the scenario planning, or the policy drafting. So the question becomes like, how these AI models behave in the key foreign policy questions, such as like military escalation, security, or decision making. The thing is that like there is not much a measurement approach. So we realized that AI is being integrated into the workflows, decision-making workflows, military war games, or like foreign policy instruments, but there is not actually a process where we can objectively benchmark how these AI models are actually behaving, what kind of recommendations they pose, or what kind of at the end of the day, the advices they give. And the problem is that there is also no ground truth where on these key questions, so that like we don't know exactly if AI is doing a better job or not. So that's how we started the project. And then the most of the benchmarks, as you can see on the archive.org, etc., we generally see that the benchmarks generally they kind of like it's mostly based on the coding completion, etc. It doesn't necessarily focus on the questions when there is no ground truth. And most of the time, and the when we look at the distribution, it's actually most of the time dominating for the it's dominating less on the defense, security, or peace kind of aspects, but mostly on the coding or technical coding completions. So that's why we try to understand like how AI models will actually behave. So we wanted to actually test these model behaviors in a new way. It's called like CFPD, what we call is critical foreign policy benchmarking. So the key question here is that the foreign policy benchmarking is here is like a bias and preference measurement. I'm gonna jump into the methodology and how we came up with the design. So we in our team there were like six PhDs on the international relations. So we coming up with the expert crafted scenarios. This is an approach in the benchmarking approach. So we wanted to understand how we can build realistic foreign policy questions, kind of trade-offs, and then we can offer some options, and then there we want to understand like how these models make a decision. So we created 400 scenarios. We did this in four key domains. These are the escalation, and then the alliance dynamic, cooperation, and I'm sorry, and the intervention. So these four domains are chosen from the international relations scholarship, and then we identified 216 qualified actors. So we swapped them in like in certain cases, what we made them in a realistic way. So I'm gonna explain you, but at the end of the day, we had 66,000 question sets, 66,473 questions, and that means the 66,000 data points. So we were able to compare the distributions. As I said, the domains are escalation, intervention, cooperation, and alliance dynamics. All of them are key international relations literature. And then the idea is that we want to understand like how these models fit into the existing international relations literature and how we can test these models in those key domains. We tested eight models. Some of them are closed source, some of them are open weight models. Closed source models are GPT-4o, Cloud 3.5, Gemini 1.5, and the open weight models are Llama 3.1, two versions of the Llama model, Mistral, Qwen2, and the DeepSeek. So some of them are US model, some of them are Chinese, and one French model. So this is how we created this scenario. So we first, based on the literature, there is this big data set, quantitative data set called militarized interstate disputes approach, where they classify the actions escalation, for example, in its a certain level. So their approach was there were three types. different types of escalation ladders. One of them is the no use of force, threat of force, of use of force. One of them is goes to the nuclear level. So we chose the two versions of the for the escalation. It's the no use of force or the use of force approach. The idea is that we created them based on the realistic cases. We created these scenarios. We created the response options, and then each scenario is then reviewed again by the two other researchers. So six international relations scholars produced the scenarios, and then each of them were got reviewed by the reviewers. And the idea is that whether these are realistic or plausible scenarios or not. These are the on the right side, you will be able to see the base model when there is no kind of like actor. But think about it in the real case, in the real data set, we were able to map these actors into the existing scenario. So there is actor A, there is actor B, but these are actually in the real case, for example, it's um, like Iran or Turkey, for example, or in a realistic case, some kind of like a border state comparing their like decision making. So we were able to got the 66,000 questions with actual actors. So at the end of the day, we were able to come up with these domains and the questions, and then we were able to compare the results. So I'm gonna directly jump into the findings to show what kind of results we got. So, first and foremost, when we looked at the cooperation, intervention, and the alliance dynamics distributions, pretty much all the models were very within the same kind of standard deviation. We're very close to each other in terms of choose of the key responses. But when it comes to the escalation, we saw very much variation compared to the others. So we have some suspicions about that, but I'll explain the logic. Here it says cloud and the GPT-4o are significantly de-escalatory compared to the Qwen2, Gemini, or the Llama 3.1, the 8-bit, like small parameters model. And then similarly, it's the same for the Qwen 2 and the Llama 3 here. In the three choice approach, again, these are the most escalatory compared to the rest of the models. Again, GPT and the cloud are the most de-escalatory ones. So this is actually a standard pattern for all the questions. And then for the rest of the domains, we don't see that much big difference in terms of the model variation. When we come to the country level, so since we were able to capture the country level data, since we have actor A and actor B, these are actual countries we put when we put them, we were able to look at, on average, given the like holding the scenarios constant, which countries are getting more escalatory recommendations or de-escalatory recommendations. So when you look at the five countries here we picked, it's United States, United Kingdom, and France. When they were in the case as a country A, they were being recommended to use of force much more than the China and Russia. And interestingly, this was the case for all eight models. I'm showing only three of them right now, but GPT, Qwen2, DeepSeek doesn't matter. It's always these three countries are getting to recommending to be, they are getting the recommendation to be more escalatory compared to China and Russia. So this was the main pattern across all the scenarios and across all the models. So obviously the main implications then when we run this is that these are the initial approaches to benchmark these AI models when we are integrating them into the decision-making workflows, such as like the foreign ministries or the like military cases or strategic decision-making processes. These models are not being used right now as the final authorized approach, but everybody in their personal life, they are kind of using these models. So these integration is gonna have big implications. So that's why we wanted to start with like there must be an open repository of these models where the scholars should contribute like how these models behave. Do these models lead to peaceful outcomes or lead to escalatory outcomes? So that's why we want to propose like an open repository for this. And in this line, the main question when we published this paper we got is that, okay, yes, models behave like this, but what about humans? Are they actually following their approach? So this is right now the two new projects that we are working on. The idea is that first one is that these models, we didn't test them in a nuclear case. Do they have tendency to recommend nuclear weapons? What is their approach to nuclear arms control, some kind of key arms control approaches? So that's going to be the one paper that we are working on. The other one is we are now testing these AI recommendations, sending to the IR scholars and the military officers. And then we have a control group is that we want to understand if people who get the GPT recommendation or Cloud recommendation compared to Gemini recommendation, do they have different decision making process? So when we give the humans actual cases, which one would you choose? Is it the use of force or not use of force? We want to be able to test like is actually AI recommendation making the difference in the human behavior. So these are the two new projects. All of them are going to be coming at by the end of the summer, so I'll be able to happy to share that. So the idea is that we want to connect that AI dimension to the human decision making very much. And I want to thank you for your time and for the opportunity for me to present my paper. Thank you.